So yeah, in a regular average, we would be adding up a bunch of numbers and dividing by how many there are. In this average value of a function, we're integrating the function, which is kind of like adding up all the values. It's not adding, but it's something that's supposed to mirror adding when you have infinitely many things you want to add. And then instead of dividing by how many numbers there are, which would be infinity, there's infinity of them, you divide by b minus a, the length of the interval, which is kind of like how much numbers they are. So let's try this definition out real quick. Example. Example. Find the average value of, I guess the one we just did, x squared, from x equals 1 to 5. The answer is, it's 1 over 5 minus 1 times the integral from 1 to 5. This is a thing that we'll do on our calculator. How do I compute an integral of a function? I need to graph the function here. It's x squared. Graph it. I need to know my graph contains the range from 1 to 5. It looks like it does. I need to say second trace is calc. 7 is the integral option. Hey, 6 is a derivative option. It's not as valuable in a calculator because computing a derivative by hand to good accuracy doesn't need you to add up 100 numbers the way this does. But hey, it's there if you want it. We want to compute the integral from 1 to 5. Lower limit 1, upper limit 5, compute. It's getting an answer of 41.33. I guess that's 41 and a third. And I need to divide that by 4. Is 10 and a third. Let me give you a warning. The reason I'm dividing by this number out front is because I'm finding the average value. The big mistake a lot of students make on this next exam is every time I say compute an integral, they start dividing by the thing out front. We only do that when it's an average value. A regular integral is the thing that it was before it doesn't have a thing out front. The average value is an integral with this extra constant out front. So this is the difference between adding stuff up and taking an average. A thing I like about average value is saying, like, this explanation of take all these numbers and then average them is way easier to explain than a Riemann sum. In my head, if I was writing a calculus book, I'm not trying to, I might talk about the definition of average value before moving on to the integral. It seems like an easier concept. It's also sort of easier to explain. This question of what will you get on average is easier than the questions you ask when you're trying to get the definition of integral. It's sort of a more fundamental thing. I would like for it to be the basic, but I don't teach it that way because, like, none of the videos you tried to use on YouTube would make any sense. And, you know, it's good to have access to the resources of the world when you're learning a thing. So we do them in this other order, even though this is maybe the more useful idea. The second thing is, graphically, this number has a meaning. Let me make a good graph of x squared. Okay, so here's a pretty good graph of the function from y equals x squared from 1 to 5. What did we just do? We computed the integral from 1 to 5. So this area, the area between the x-axis and the curve, that area was 41 and a third. Here's another area that's 41 and a third. If we take that and divide it by 10, what did we have? We had 10.33. No, divided it by 4 and got 10.33. So I know that a rectangle that's 10.33 by 4 also has that area. So well, here's a rectangle whose width is 4 and whose height is 10 1/3. Here's 10, here's 10 1/3 is a third of the way through here, so like joop, 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 joop. So this rectangle has the same area as the region under the curve. This area is the same as this area, right? So here's another way of visualizing the average value. The curve has highs and lows. It goes up and down. If I wanted to smooth it out by taking the high parts and cutting them off and moving them into the low parts, and like imagine this is made out of Play-Doh and you're just trying to smash all the Play-Doh down into the tube or the jar. It's not a jar, but you know, the Play-Doh holder. Like it's the thing you get by flattening something out is another way of thinking about averaging. Take the highs and move them to the lows until everybody has the same amount. That's what an average is. And that's a way of visualizing this graphically. Part of what's going on is that the stuff that's above average, this, works out to be exactly the same as this. Like if I worked these out, they would come out to have the same area. There's like a visual interpretation of the average value. Is you're taking the shape of a thing and smoothing it out to be a rectangle, and the height of that rectangle is the average value. That gives us a really powerful way of thinking about integrals. So here's a random function that I've drawn. It looks like it's going from 0 out past 24. And if I have the question, let's estimate the integral from, let's make it 10 to 24 of that function. I'm going to call this function g of x. We've done problems like this. We're looking at this, we're looking at this, we're trying to estimate this area. We can get there by counting boxes. The thing I want to emphasize is human brains are not very good at counting boxes in our head. Like area is a thing that brains are not good at. We're good at counting to numbers up to about 7. You can look at 6 things and know they are 6 things without thinking very hard. Other animals have different skills. There's I heard about a sea turtle that lays hundreds of eggs at a time, and you can move the eggs around and remove one, and when the turtle comes back, it will know immediately one of the eggs is missing. Like they can glance at a stack of hundreds of objects, and because it's valuable for their evolution, they can do that quickly in a way that we can't, because it was not good for us. It's not a thing our brains learned. Estimating areas is a thing we are not good at. Like in your head, how many square feet is the Walmart parking lot in Lancaster? That's just not a thing that humans are good at. You can get good at it by practicing, but it's not a thing that we have inherently. Average value is fun to me because it changes a thing we are not good at, estimating area, and changes it to a thing that we are good at. What am I headed to? If I wanted to estimate the integral by first estimating the average value. The point of the average value, like we just said, is it's a number between, so that the stuff above ties with the stuff below. If the average value was 20, then this area would equal this area. Does it equal this area? It looks like no, the bottom one's way too big. So that tells me the average value of 20 whatever the average value is, it's definitely lower than 20. If the stuff below it is too high, that means the stuff below it is too big, means the line is too high. I'm going to need to bring the line down to make the stuff above it bigger and the stuff below it lower. So it's not 20. 20 is too big. What else can we try?